All right, so in this video, we're going to look at how we can use a computer to compute numerical solutions for a difference equation. And we're going to do this in Octave, but it would be straightforward to do this with any programming language. All right, so the thing about these difference equations is that we're repeating the same calculation over and over again, just with different inputs, right? We have some formula for the change in the state, delta A, and we just keep plugging different things into that formula and then adding them to the previous value. Since that's a very repetitive process, we don't want to have to re-explain what we're trying to do each time. And in programming, there is a tool called a for loop that allows you to take an instruction and just repeat it a certain number of times. So in Octave, the way that you write a for loop is you start with the keyword for, and you'll notice that if that's typed in correctly, it will be highlighted in blue. Then you give it a variable. In this case, we're using the variable k, which is what's called the loop variable. So there's our loop variable. And then you give it a list of numbers. In this case, the list is 1:5. And in case you're wondering, 1:5 is the same thing as 1, 2, 3, 4, 5. That's just creating the whole list without having to type them all out. Okay, so a colon will give you a list of numbers spaced out by 1, and there's actually a way to use 2 colons to specify the spacing in between them. But we won't worry about that for now. Okay, so what is this code going to do? Well, it's going to repeat this task 5 times, once with k equals 1, once with k equals 2, once with k equals 3, and so on. All right, and in this case, the thing inside the loop, in other words, the instructions between the for, which starts the loop, and the keyword end, which defines the end of the task that we're going to repeat. The code in between is just the command disp, which is short for display. And so this code is just going to display the numbers k. And so what's going to happen is the first time the computer, as it reads the code, it goes line by line. The first time it reads it, it says 4k equals 1 through 5, and it makes a note, okay, I'm going to have to repeat this task over and over again, so I'm going to keep coming back to this point. And so then it goes on to the next line. It says display k, and the first time it goes through the loop, k is going to be equal to 1, so it's going to just display a 1. Then it hits the keyword end, and it says, and that marks the end of the loop, and so it will go back to the top, and it will take the next value of k, k equals 2, and it will repeat. So at that point, it sees display, so it will display a 2. It will reach end, it'll go back up to the top. Now k is 3, so it'll display 3, and then it will do 4 and 5 in that order. And if you give a more interesting instruction rather than just displaying a number, you want to perform some calculation, then you can get this to repeat all kinds of tasks relatively easily without having to type a whole lot of instructions. All right, so let's see what that looks like in the context of a difference equation. So let's suppose that the equation that we want to describe has the following description. So A0, the initial value is just 2. So our solution is going to begin with the value of 2. And then the change is going to be given by some function. And in this case, I will use the function that the new value is just 1/2 of the previous value. Okay? So every new value, the change is always going to be half of what we had before. All right, so we could plug that into a calculator and do it, but it would be very, very time consuming, especially if our goal is to compute the value of a after 100 steps. And so a better way to do this is to use a for loop. And so to start out, we will define a function. You'll remember we've done this a little bit earlier. So this function is going to be the change, right? Our rule was that the new value is always half of the previous one. And so this function has an input of a, and then the output is going to be 0.5 times a. All right, and remember equals at is the way that you specify that you're defining a function in Octave and MATLAB. And so from here on out, if you type f of 1 or f parentheses 2 or f parentheses 3, it's going to take whatever is between the parentheses and plug them into the function. All right, so that's the first thing. Second thing is we're going to define our initial value. And notice there's something a little bit annoying here. In MATLAB and Octave, when you make a list of things, the first number has to be the first one, right? It has to have an index of 1. but as we defined our sequence, our initial value was called A0, and so we're going to have to adjust just a little bit. So we're going to say that A parentheses 1 is 2. And what that means is we're going to create a list where the first entry in the list is 2, and then we're going to add entries to the list one by one. Okay? All right. So then, how do we actually fill in the rest of the terms in the sequence? Well, we'll create a loop. We want to repeat the task 100 times, right? We want to add 100 values, A1, 2, 3, all the way up to A100. And so we'll let k go from 1 to 100. And then inside the loop, what we're going to do is we're going to take the k plus first entry in our list, which at this point doesn't exist because when we start the loop, k is going to have a value of 1. And so this will be A parentheses 2 the first time through. And that's going to set that value equal to A1, again, since k is equal to 1, plus f of A1, where f of A1 is calculated using the function that we defined up above. And so you'll notice if we do that, what we'll get is 0.5 times 2, so 1 plus 2, and so A2 should get a value of 3. All right, so that's one pass through the loop. And notice what we did was we added one number to our list A. And so now A has two numbers in it, 2 and 3. Okay? At that point, if you're again reading line by line, then you're going to reach this end command, which tells the computer to go back up to the start of the loop and repeat again with the next value. And so when it repeats the loop, again, it will call this with k equals 2. And so it will say A of 3, since 2 plus 1 is 3, equals A of 2 plus f of A2. And notice that's going to be precisely what the formula tells us to do to compute the next value. And then it's going to repeat that for every subsequent value all the way up to 100. And notice the very last time, it'll create the 101st value in the list, which corresponds to A100. Now, it's easy to mess up and accidentally do one too few steps in this case. So make sure that you're keeping track of, if I have 0 is the index for the initial value, and I want A100, that means I need a total of 101 values rather than 100. Okay? All right, so that's the code to simulate a difference equation, and then if at the end of the loop you just type the letter A, it'll actually display all the numbers up to 100. Or if you want to just see the final value, you can type A parentheses end, and that would just give you the last value in the list.